Today we are going to learn about optimizing database connection pools for performance. This session will cover strategies for configuring and tuning connection pools across various database systems to enhance performance and reduce latency.
Welcome to our video on optimizing database connection pools for performance. In today's world, where applications are expected to handle thousands of concurrent users, efficient database connection management is crucial. Connection pooling plays a significant role in reducing latency and minimizing resource consumption. In this video, we'll explore the basics of database connection pools, their benefits, and practical strategies for configuring and tuning them across various database systems. By the end of this session, you'll have the skills to enhance your application's performance by effectively managing database connections. Database connection pooling is a method used to maintain long-lived database connections, allowing them to be reused by different requests. This approach significantly reduces the overhead of establishing a new connection for every request. A connection pool typically consists of a pool manager, a set of active connections, and a set of available connections. When an application requests a connection, the pool manager provides an available connection, and once the task is completed, the connection is returned to the pool. This reuse of connections reduces latency and improves application performance. There are various types of connection pools, including fixed, dynamic, and adaptive, each suited for different use cases. Understanding the basics of connection pooling is essential for optimizing database interactions in high-traffic environments. Connection pools offer several benefits that are critical for maintaining high performance in applications. Firstly, they reduce connection latency by reusing existing connections instead of creating new ones for each request, which can be time-consuming. Secondly, they improve resource utilization by maintaining a limited number of connections, thereby lowering the load on the database server. This, in turn, leads to enhanced application scalability, as the server can handle more simultaneous requests without being overwhelmed. Furthermore, connection pools help maintain consistent performance even under high load, as the overhead of connection management is significantly reduced. These advantages make connection pooling an indispensable technique for optimizing database interactions in high-traffic scenarios. Setting up a connection pool in Java applications typically involves using JDBC, Java Database Connectivity, and a connection pool library. Some popular connection pool libraries include Hikari CP, Apache DBCP, and C3P0. Configuring these libraries requires specifying parameters such as the maximum number of connections, connection timeout, and idle timeout. It's important to choose a library that suits your application's specific needs and to fine-tune these parameters for optimal performance. Common setup challenges include ensuring thread safety, managing deadlocks, and balancing between connection pool size and resource constraints. Properly configuring a connection pool can significantly improve the efficiency of database interactions in Java applications.
Tuning connection pool settings is crucial for achieving optimal performance. Key performance metrics to monitor include connection wait time, total connections, and idle connections. Adjusting the pool size is often necessary to handle peak loads while preventing resource exhaustion. It's also important to balance timeout settings such as connection timeout and idle timeout to avoid unnecessary resource consumption and ensure timely release of connections. Connection validation, which involves periodically checking the health of connections, can prevent errors at runtime. Best practices for tuning include regular monitoring of performance metrics, incrementally adjusting settings, and conducting load testing to validate changes. Proper tuning can lead to significant performance improvements and resource savings.
Managing idle connections and timeouts is an essential aspect of connection pool optimization. Idle connections, if not handled properly, can lead to resource leaks and increased memory usage. Configuring idle timeout settings ensures that unused connections are closed after a specified period, freeing up resources. Strategies to prevent resource leaks include regularly monitoring connection pool metrics and implementing connection validation checks. It's also important to balance idle and active connections to avoid exhausting available resources while maintaining efficient database access. Improper timeout settings can lead to increased latency and degraded performance, making it crucial to carefully configure and monitor these parameters.
Monitoring connection pool metrics is crucial for identifying potential issues and optimizing performance. Key metrics include total connections, active connections, idle connections, and connection wait time. Tools such as Prometheus, Grafana, and built-in pool monitoring features can help visualize these metrics. Interpreting metric data involves analyzing trends and identifying anomalies that may indicate performance bottlenecks. Using metrics for optimization involves making data-driven decisions to adjust configuration settings and improve efficiency. Common monitoring challenges include dealing with large volumes of data and ensuring real-time updates. Effective monitoring is essential for maintaining the performance and reliability of database connection pools. While connection pooling offers numerous benefits, several common pitfalls can hinder performance if not addressed. Over-allocating connections can lead to resource exhaustion and increased latency. Ignoring connection leaks can result in memory waste and degraded performance over time. Misconfiguring timeout settings may cause unnecessary resource consumption or connection drops. Neglecting to monitor pool metrics can prevent timely detection of issues. Strategies for avoiding these pitfalls include regularly reviewing and adjusting pool settings, implementing connection validation checks, and establishing a robust monitoring framework. By proactively addressing these challenges, you can ensure optimal performance and reliability of your database connection pools. Let's explore some real-world case studies of successful connection pool optimization. In one example, a high-traffic e-commerce platform faced challenges with database latency during peak shopping seasons. By implementing a dynamic connection pool and adjusting timeout settings, they reduced latency by 30% and improved resource utilization. Another case involved a financial services firm that experienced connection leaks due to improper handling of idle connections. By introducing periodic connection validation and monitoring, they eliminated leaks and stabilized performance. These case studies highlight the significant impact of strategic connection pool optimization on application performance. Key takeaways include the importance of regular monitoring, the benefits of tailored configuration, and the value of learning from past experiences.
In conclusion, optimizing database connection pools is a critical aspect of enhancing application performance. We've covered the basics of connection pooling, its benefits, and practical strategies for configuration and tuning. Effective management of connection pools leads to reduced latency, improved scalability, and consistent performance. By applying the knowledge and insights gained from this video, you can ensure your applications are well equipped to handle high-traffic environments with efficiency and reliability. Thank you for joining us, and we encourage you to implement these strategies in your own projects.